Hi, my name's Scott. I'm an economics tutor here at ASU, and today I'm doing an unedited video of different types of data, so I may make some errors, but I'll try to backtrack if I do. So anyway, I'm just going to break down some different types of data, different way to categorize data. And so to start, there's qualitative and quantitative data. Those are two big categories. You may know what these are. Quantitative typically deals with numbers, hence the quant in there, and the qualitative is more descriptive, some physical characteristic that can't really be represented by numbers. I'll just say
using 1 hour of labor. So
not a hashtag, just to show that those are numbers. And then each of these categories can be broken down further into smaller subcategories. So I'll do quantitative data first. So there's interval data and ratio data.
just 8.
The key with interval data is there's no true zero. An example might be temperature. So yes, we have on different temperature scales, we have 0 degrees Fahrenheit or 0 degrees Celsius, but those are different scales. So you wouldn't say that 60 degrees Fahrenheit is twice as warm as 30 degrees
so that
Fahrenheit.
would just be meaning that they spent
just because
1 million producing
0 degrees Fahrenheit
1 times
there's no reason why 0 degrees Fahrenheit is a better 0 point than 0 degrees Celsius. So that's an example of interval data where ratio data does have a 0. Okay, so here we had temperature.
right.
An example of ratio data
Yeah, sure.
is weight. So if someone weighs 0 pounds or 0 kilograms, that is a true 0. So you can say that 20 pounds is twice as much as 10 pounds. And that's what makes weight, for example, ratio data. So those are the two types of quantitative data. And then with qualitative, we break that down into nominal versus ordinal data, where sometimes you'll hear it called categorical, which is a pretty good description of it. It is usually describes categories. So those two different types are so nominal data, like I said, and ordinal data. So nominal data, there's no way to assign numbers at all to nominal data. So you might say type of car, so that would be, you know, a Honda or Ford or something like that, and it's purely just different categories of types of cars that people might own. Whereas with ordinal data, it's still categorical, but it can be ranked. And that's the key here, is that ordinal data can be ranked. So if you look at maybe like years in school.
Mean is the average.
Yes.
So
48 plus 20 is 68, and then 68.
In high school or college, for example, you might call someone a freshman, a sophomore, a junior, or a senior. So those are qualitative or categorical data, but you can rank them. You could say freshman is 1, and so on until senior is 4. So there's a meaningful way to rank these because one comes after the other and so on. But it's still qualitative in nature.
So x sub I.
Just to get a whole picture of how this breakdown works.
So these are
This
different
is
x values.
sort of the tree here. If you can come back to this point in the video if you need to refer back to this. Another thing that's sort of similar is different types of statistics. So there's typically two broad categories in the study of statistics: inferential statistics versus descriptive statistics. So a lot of people are more familiar maybe from elementary or middle school with descriptive statistics. It's factual information. Like it sort of suggests the name, it's just describing some facts about two populations. So an example, you might look at 2 books on an online website, a bookseller's website, and you might say that one book has a higher average rating than the other book. And that's based on the entire population of reviews for each book.
Like a physics problem,
and it's a fact, right?
There's no time associated with each of the observations.
You're not using that information to make a broader claim. Okay, so inferential statistics compares samples, and then the key difference from descriptive statistics. And so it makes claims about about the larger population. So
now, which is bigger?
an example would
If we
be
use the same data set
a study that goes to different universities
versus
and
this
samples
is going to be bigger.
a variety of undergraduate students and a variety of graduate students. And then
Okay.
maybe they find that from their sample,
So
graduate students on average have less debt than undergraduates.
when you take the square root of it,
And then they use that sample to make a broader claim that that's true about the entire population of graduate and undergraduate students. So again, it's not factual in the sense that their sample
the bigger one
just could have had that property, but in reality, maybe graduate students have more debt on average. So what they're really doing is just taking a sample and making inferences about the population, and so that's why it's inferential statistics. So at the beginning we went over different types of data. So there's qualitative and quantitative. Qualitative can be broken down into nominal and ordinal, and you can go back to that part of the video to review those. Quantitative can be broken down into interval and ratio, and again you can review those in the video. And then we have two different ways of studying statistics. We have inferential and descriptive. These are the different characteristics of those, and that pretty much sums up just those types of data and statistics. I hope that helped. So yeah, if you have any questions about any of this or any other statistics or econ classes, just come into the tutoring center, Economics Tutoring Center, BA 211 in the W. Carey School of Business. Hope that helped.